Good day, everyone. Today, we are Group 2 presenting PolluTrace. In sanitary engineering, it is important to trace back the point and non-point sources of pollutants in order for us to alleviate its effect on water bodies. For this program, it helps tracing the source and predicting the pollutant load within a specific point of a stream. It has three main features. First, we have the displaying of Dow 2016-08 standards in its tabular form for option 1 using pandas. Next, we also have the specific displaying of the Dow 2016-08 standards where the user only wants to access a specific pollutant standard in a desired water class. Then, most importantly, is the curve fit operation, where it has four features, which is to store the data for relative distances and the chosen pollutant load or value per desired number of points. Its next operation is to view the stored values in a tabular form. Then, next is the editing of the existing data, which the user can either add new pollutants and input those necessary data, and also delete the pollutants in the stored values. Lastly is the plotting of the graphical representation itself, which uses matplotlib and polynomial equations in the code.
Now let's talk about the self-defined functions. The utility functions are way-of-life functions that are used to shorten the code by reducing its repetition. Here are the following utility functions.
For text box function, it formats and displays a list of string inside the box. It automatically adjusts the box width based on the longest line, then prints borders and spaces to create a clean, easy-to-read layout for menus or messages. Next is the choice function. It is a list of numeric string options like 1, 2, and so on based on the length of any given list. It loops through the input list and appends string versions of numbers starting from 1. This is especially useful for standardizing user input in menus, so users can select options using numbers.
The utility function polynomial printer coeflist is a function that prints the polynomial's coefficient in an increasing order from the coefficient of a constant to the linear term to the quadratic term and so on. Next is the utility function input failsafe. It has two arguments where the input text is displays anything the user inputs, meanwhile the data type limits and repeats on whichever data type the input needs to be.
Selection functions are used for selecting list of choices including parameters, pollutants, and water classes. The next slides show the selection functions.
The parameter selection functions allow the user to choose a pollutant category. It filters options from the parameters list and ensures the input is valid before returning the index for the selected standard. Next, pollutant selection builds on by asking the user to choose a specific pollutant within the selected category. It returns a dictionary with the pollutant name and associated index used later in the standard lookup. The class selection function asks the user to select a class of water body, like class A, B, or C. It ensures the input is valid and returns a selected class index for reference when matching standard.
Feature functions are integral to the program. They are irreplaceable sections that holds the objectives of the program. The next slide shows the feature functions.
The feature function display standards is a shortcut function that uses the parameter selection function in order to display the tabular form of the Dow 2016-08 standards using pandas.
Get standard value fetches the legal limit of a pollutant by using both the selected pollutant and classes. This helps checks if sample values are within the allowable limit set by law.
And for the Newton coef, the Newton coef function creates a polynomial equation using Newton's divided difference method to model how a pollutant's concentration changes with distance in a stream. It begins by letting the user choose which pollutant to analyze from the dataset. Then, it calculates the Newton basis polynomials and uses divided difference to find the coefficients for each term. And these parts are multiplied and summed to form a single polynomial. And the final output is an equation that can be used to plot and visualize trends in pollutant levels across different locations. And for the main function, it serves as the central hub of the PolluTrace program, guiding the user through various options to explore water pollution data. When the program starts, it displays a main menu with 4 choices: display water quality standards, check the standard value for a specific pollutant, perform curve fitting operations, and exit. If the user chooses to display standards, they're prompted to select a category, and the program shows the legal limits for each pollutant. If they want to view a specific pollutant standards, the program will let them pick a pollutant and a water class, and then it will display its maximum allowable level. The most detailed part is the curve fitting operation. Here, users can input sample pollutant values across different distances in a river, view or edit that data, and generate a graph that shows how the pollutant behaves spatially. And the graph includes a polynomial fit generated by the Newton coef function and overlays it with the legal standard, allowing easy visual comparison. The loop continues until the user chooses to exit, making the program interactive and useful for monitoring waste quality trends.
The following slide are the error catches.
Again, this is Group 2 presenting PolluTrace. Thank you for listening.